equation sort from topic 09, absolute value equations. We want to sort these 10 equations, some linear, some isolated to absolute value, into the 4 categories that are shown. Category 1 is just linear equations, so Algebra 1 style equations. Second pile is they're ready to be split into 2 equations, so these are absolute value equations that are ready to be split. The third category is we're looking for equations that we could identify as having possible extraneous solutions. And the very last one is where there's going to be no solution, equations where we know already that there's going to be no solution. So let's start with the special cases, and let's take a look at no solution category. What is the key feature that gives us an equation that has no solution? Well, an absolute value cannot equal a negative number. So when we get to this particular scenario, we know that there is going to be no solution, and there's no point in algebraically solving because we're going to have solutions that are in error. So taking a look at our 10 options, we see that the first identified in option P, absolute value of x plus 1 is equal to a negative 3. Looking through again at the different options that we have, we see that option R has absolute value equal to a negative number. Option T has absolute value equal to a negative number. And that's it. All right, possible extraneous solutions. So these are ones where we may get 2 answers in terms of our algebraic solving, but one of them may not work. And when we check it on the graph, we see that one of them fails. Well, what's the key feature from the equation that lets us know that, hey, there may be a possible extraneous solution? Well, anytime we have a variable both inside and set equal to an absolute value, this generally means that there's a possibility of an extraneous solution. Here's an example. If I have the absolute value of x minus 3 is equal to 2x, we see that there's a variable inside the absolute value bars and a variable on the other side set equal to it. Generally, this means that there is a potential for a possible extraneous solution. So looking at our options again, we can go through one by one. We see that option N has a variable inside and outside. Option Q has a variable inside and outside. Option W has a variable inside and outside. So N, Q, and W have possible extraneous solutions, and we see that P, R, and T have no solution because the absolute value cannot be equal to a negative number. Well, in terms of what's left over, we have regular Algebra 1 absolute values, and we have absolute value equations that can be split into 2. So looking through each of these options, we see that option O, option X, these have no absolute value bars at all. These are just simple Algebra 1 linear equations. So O and X are options for there. So that means the remaining equations are ready to be split into 2, one positive and one negative. Our absolute values are isolated. Option M here and option S are both ready to be split into our 2 absolute value equations. If we take a look at M, absolute value of x plus 1 is equal to 7. In terms of splitting this into 2 absolute value equations, one of them is going to be the same, where we simply just copy the equation over without the absolute value bars. On our other, we're going to go ahead and flip this around. Now this says flip the inequality, but really what we're looking for here is we're just looking to change the opposite of the right-hand side. So this turns into x plus 1 is equal to negative 7. Where the left-hand side of the equation has stayed the same, however, the right-hand side has become a negative of whatever is listed there. Okay, there is our types of equations card sort, taking a look at some just absolute value and linear equations and seeing where they fall.